Okay, we're on the top of page 5, module 5, lesson 1. We had just done these two together. I actually should have told you to do the next 6 because they're all the same, but we'll check these two and then you can shut off your camera and try to do the other ones after that. So this says x is in between 1 and 4. And I can see 1 has an open circle, 4 has a closed circle because of the equal sign. So I immediately go to do that. 1 has an open circle, 4 has a closed circle. And remember, if you're using parentheses and brackets, it would look like this because they do both in ALEC. So you need to be familiar that they're the same. And this says x is in between 1 and 4. So we'd shade in between 1 and 4. And I'm pretty sure when you do the graphs, they do have you use the parentheses and brackets. So I just know students are familiar with this from high school, so I show it like this, but show what it turns into. Later on, we'll ignore the open and closed circles and just do the parentheses and brackets, but I'm trying to transition you here. Okay, so now we have to write our interval notation, and remember, order matters. So whatever's on the left stays on the left. The left endpoint is 1, and because it has an open circle, it gets a parenthesis. The right endpoint of our shading is 4, and because it's a solid circle, it gets a bracket. So that's what interval notation would look like. And it would translate as everything in between 1 and 4, including 4. That's how you would say it in words. Everything between 1 and 4, including 4. Okay, on the next one, this does not look like an L. So that means it's greater than or equal to. So two things I note with greater than or equal to. It's pointing right. That means greater than shades right. And 2, it has a solid circle at 1. So solid circle at 1, and the numbers are greater than 1 going right. See how important it is to know the difference between less than and greater than? That's why I showed you that trick. Looks like an L, less than. Backwards L, greater than. And on this end of the number line is positive infinity. So the negative infinities down on the negative end, the positive infinities on the positive end. And when I go to write my interval notation, I bring the numbers down in the same order. My two endpoints are 1 and infinity. So 1 comma infinity. I know infinities always get parentheses, and the equal sign says make a bracket, because a bracket has an equal sign in it. Okay, so hopefully that cements it in your head. So here's the last 4. All of these below are the answers, so you don't have to look at those. So we're just doing these 4 here. Okay, same thing we just did, practicing with your brackets, your open circles, your closed circles. So go ahead and shut off the video. Do those 4 and then come back and we'll go over them. Okay, so this one is 2, 3, 4, 5. And closed circles on each, because they both have an equal sign. So closed circle at 2, closed circle at 5, which means this graph would have brackets on both ends, because closed circles mean equal. The brackets have the equal sign. And this is all the x's between 2 and 5, and then you would say comma inclusive. That means include both endpoints. X is between 2 and 5, inclusive, means including both endpoints. So this would be your solution set, everything in between. And then for your interval notation, just drop down in the same order. The two endpoints are 2 and 5, so you write 2, 5, solid circle, or an equal sign means bracket, solid circle, or an equal sign means bracket. So see, getting this out of the way and learning this part of it, could you imagine trying to learn this, both of these things, how to graph, how to write interval notation, and how to solve inequalities at once? It's overwhelming. So now you'll know this when we go into section 5.4, which is nice. Okay, let's check your next one. This is not an L, so that means X is greater than 6. So let's just do 4, 5, 6, 7. And they have the number lines drawn for you on Alex, so that's nice. So I notice there is no equal sign. That means it's going to be an open circle. And greater than always shades right. And you can see the arrows pointing shade right, shade right, shade right. And I know to the right end of the number line is infinity. And so when I bring my two endpoints down, 6, infinity, never changing the order. It's wrong if you change the order. Every computer and teacher alive will count it wrong. Order matters. So always bring them down in the same order. And we know an open circle means parenthesis, and infinity always gets a parenthesis. So this one would look like this if you were using parentheses. So parenthesis 6 to infinity. Get easier and easier, right? Okay, so on this one we have -4 to +3, -4, -3, -2, -1, 0, 1, 2, 3. That's a lot of numbers to write, huh? -1, -2, -3, -4. And -4 gets a bracket or a closed circle, whichever one you're using. Because of the equal sign, 3 gets an open circle or parenthesis because there's no equal sign. And this is red. X is everything between -4 and 3, including -4. So you can't say inclusive when there's not 2. You just have to say including whichever one it includes. So everything between would be shading heavily in between. When you do these on Alex, you plot this with a close bracket. You plot this with the parenthesis, and then in Alex you click and it shades wherever you click. So if you click here, it's going to shade to the right. If you click here, it's going to shade to the left. If you click here, it shades in between. So you just click on it. So then we have one endpoint's -4, the other endpoint's 3. -4 has an equal sign, so bracket. 3 has no equal sign, parenthesis. Nice, right? Okay, and last but not least, X is less than 4. And I know it's less than because it's an L. So 3, 4, 5, 6. Less than means open circle or parenthesis, and I know all the L's go together. Looks like an L, red less than, shade left. So I know this is a shade left graph. And I know on the far left is negative infinity because the negative numbers are on the left, the positive numbers are on the right. So there's my graph with the parentheses and with the open circle. Now I need to bring my two endpoints down. Negative infinities on the left, always a parenthesis. Positive 4's on the right, and it's a parenthesis because of the open circle and no less or no equal sign. So I hope that helps. When we get to 5.4, you already have that under your belt. And these are just the answers to the ones we did. You can look up here and see there's 1 and 4. There's bracket 1 and infinity. So that's all the answers here. And here's all the graphs. I just thought it would be easier to do them rather than make cards out of them and cut them up and match them up. So page 5, page 6, and page 7 are now done. So we're all on the back of the packet. So the very last page, which would be page 8. And you'll notice that we have a 4-credit class, 091. So that means we're supposed to be in class, taking notes, 4 hours a week. So that's what you'll notice is I'll put like an hour of videos each day, 4 days a week for you to do. So keeping up with that is key because then you'll be ready to do your homework. So if you try to do your homework without doing this, it's going to take a lot longer. Plus I give you points for these. I have you submit your filled out notes. So do your notes, then go do an hour of ALEKS. Do your notes, then go do an hour of ALEKS. Do an hour of notes, then an hour of ALEKS. So I think for most of you, an hour taking notes, an hour doing homework, 4 days a week, you should be able to do it. Everybody works at different paces. Some people can probably do the homework faster. Some people might take longer, but that's just kind of a general guideline I give my 091 students. 4 hours in class, and then I say 4 to 8 hours doing homework. That's a college guideline, by the way. For every hour in class, you do 2 hours of homework. So the college guideline would be 4 hours in class, 8 hours of homework. But I like to say 4 to 8 just because I know students work at different paces. So try it out first. An hour of notes each day, then an hour of homework. Hour of notes, hour of homework, and see if you get done on time. If not, then you might have to do an hour of notes and an hour and a half of homework. You know, so you'll have to adjust based on the speed you get it done. And like I said, everybody's different. I've had students finish all the homework for the week in 20 minutes, and some students take 8 hours. So it just kind of depends. But you don't want to skimp on your homework in ALEKS, because like I said, all your tests and all your quizzes come right from your ALEKS homework. I just go, oh, I like that problem, and I put it on the quiz or test. Oh, I like that one too. Put it on the quiz or test. So homework is key in math. If you haven't learned that before, you will learn it in college real fast. It's the key to being successful, doing your homework. Okay, so let's do this last page, and then we will be done with our second day of class. So this one is practicing variables again. So we define a variable and then write a mathematical statement to represent it like we did before. M equals the number of dogs for the Miller's family or whatever. So I'm going to show you some good tricks though that help, because I'll tell you, a lot of students think writing the variable statement's nothing. It's the key to the problem. Because once you write your 1 or 2 variable statements, then it's going to say the sum of their dogs is 54. So you go, oh, Nichols family plus Miller family equals however many dogs they have. So this is the most important step in word problems, really. Because once you write the variable statements, you're just going to multiply them or add them or subtract them or whatever the problem tells you to do with them on the next step. So this is a key that I teach every single one of my students. When you are writing variable statements, look for the word than. It's not always going to be there, but if it is, that's the key. Whatever follows than is always going to be your X. So I'm going to use M because it's Miller family. So M equals. So whatever follows than is always your single variable. No numbers added to it, no numbers subtracted, nothing multiplied. It's just the variable. So generally students will say, oh, that's my X. Well, we're just going to call it M instead of X because that tells us what we found. So M is the number of dogs the Miller family has. So number of dogs for the Miller family. And that probably is one of the most important things that I'll teach you in this whole class. Than is huge. So it's always whatever follows it will be your X, and then you can change what you want to call it. You don't have to call it X. So in this case, M made more sense. And then it's super easy to write your next statement because you've just learned all your translations. The Nichols have 2 less dogs. Oh, we know how to write that. The Miller family minus 2. Because we know less means subtraction. So the Miller family's dogs, their number minus 2 is the number of dogs for the Nichols. So does that make sense? So whatever follows then is your X. In this case, we're going to call it M. So you just write M equals whatever it is. Then you reread the sentence. Oh, Nichols have 2 less. Oh, they're M minus 2. Because we can't use 2 variables in a problem. You can't say N equals the number of dogs for the Nichols. We don't know how to solve equations that have 2 variables. So we have to use that then to pick out what the first one is, and then write the second one using that. 2 less than the Millers, M minus 2. So then we're all set up and ready for the problem. If they say the 2 families have a total of 8 dogs, you'll go, oh, total means add. M plus M minus 2 equals 8. So see how important it is to write variable statements? Because once you write them, then you just read the next sentence and it's going to say sum or product or quotient, and you take your 2 variables and do what it says. If it says the sum or the total number of dogs for the 2 families is 8, you go M plus M minus 2 equals 8, because the Millers plus the Nichols equal 8. So variable statements are key. And most of the students that come into my class think variable statements are nothing. You know, they're like, I don't even write them. Well, they're the key to the problem. That's what makes word problems easy, is writing good variable statements. Okay, next we have, and this is the other type, the type without than. And you're going to see pretty much equally these 2 types, so it's good to study both of these. The sum of 2 brothers' ages is at least 34. So let's just pretend right now it is 34. Okay? The sum of the 2 brothers' ages is 34. So that means, let's just change it to is, because that just kind of adds confusion to it for you guys. So the sum of 2 brothers' ages is 34 years. So I could say B1 is the first brother's age. And that's read B sub 1. So like if you have 2 brothers and you want to call them both B, you can call one brother sub 1 and one brother sub 2. So that's a common thing when the 2 things you're, I wouldn't say comparing or writing an equation about, you can put subs on them to show they're both the brothers. This is the first brother, this is the second brother. So the second brother's age, actually, I don't want to put that in. I don't want a second variable on this. I was just showing you the subscript. Okay, so B sub 1 is the first brother's age. So now this is where you have to think, and sometimes students say this gives them a headache, thinking so hard on this. So let's say 2 brothers, we're going to come out here to a real life situation. 2 brothers' ages are 34. Their sum. Sum means add. So what if one of the brothers was 10 you're going to say, oh, 34 minus 10, the other brother's 24, right? Because don't these two add? What if the first brother is 20? Oh, 34 minus 20, that means the second brother's 14. So do you see a pattern there? When I know one brother's age, and I'm going to take this off. So when I know one brother's age is B, and there always has to be something that's just a variable, so that's why I wrote it. But I showed you how to do it if you had two of them. So whatever this first brother's age, I do 34 minus that to get the second brother. So the second brother is going to be 34 minus the first brother. And those are really the only two kinds of word problems you have in this class. Is one with than, where you call that the letter and then read this again to see what to do with it. And then one where there's a sum. So anytime there's a sum, call 1B. You can call it the first brother's age or the second brother's age. And then to find the second brother, you take the first brother and subtract it. 34 minus 10, 34 minus 20. If this is B, 34 minus B. That's how you get. So you're just putting B here where you would put the age. So it's the sum minus what you already have. This is their sum minus how old this guy is. And that will give you the second brother's age. So those are the two types you'll see, where they use the word than for comparison, or where they give you the sum and you have to call one B, the other one 34 minus B or 50 minus B or whatever it is. But what happens is students write B minus 34, and that's wrong. Did I write 10 minus 34 or 20 minus 34? No, it has to be the sum minus the first brother. Sum minus the first brother. So order matters, it's subtraction. So you're going to see a lot of that later, but I just like to introduce it early on just so you can be exposed to it a couple times. Okay, I'm going to let you try 3. So go ahead and see how you do on 3. Shut off the video and then come back once you get your 2 people. So you should have something is Sarah's number of credits and something is Corey, and it should be the same variable. Okay, there's my word then. Boom, I immediately know who's X, or in this case, maybe a better letter C. I love the word than. It makes the problem so easy. So than, whoever follows than is our X, or in this case, we'll say C equals Corey's number of credits. Okay, everybody understand why? Same reason here. Whoever follows than is just a variable, and use a variable that represents them. Then you go back and reread the problem to get the other person. Sarah is taking 3 more. So Corey plus 3. I can't use S. Remember, everything has to be in one variable because we can only write equations with one variable. So Corey plus 3 equals Sarah's number of credits. I'll just put Sarah's credits. So that's a cool trick, isn't it? Like I said, that's probably the most important thing I teach you this whole semester. that. I mean, there's a lot of important things, but that's one of the most, especially word problem wise. Okie dokie. Fire code states that there can be up to 50 people in a classroom. So this really isn't a variable one. This is more transferring it into a equation or inequality. I'm not sure why there's some in here that like don't go with these first three, so I just kind of roll with it. So this says fire code, so should we say F? States that there can be up to. So now we got to think, up to. So I know that's going to be an inequality. Do you guys know that when you read that up to verbiage? So is it greater than or equal to 50 or less than or equal to 50? So I asked myself, can there be 49? Yes. Can there be 51? No. So its fire code says less than or equal to 50. And F would be the number of people, but so fire code says up to, that means you can equal 50. Then I just have to decide if it's less than 50 or greater than, so I do the scenarios. Can there be 49? Yes, that's less than. Can there be 51? No, so I can't use greater than. So that was kind of like what we did on our translating problems a couple pages ago. Okay, go ahead and do 5. It's just like number 4. Okay, the number of minutes it takes to drive to Phoenix is more than, there's your key words. We learn what that means. Is more than, is less than means an inequality. So is more than means greater than. So we could say minutes is more than 20. So nice and easy, right? And so we should write down what our variable statement will be for both of these, and then we'll call it a day. I don't really like these two problems, so I don't usually go over them in class either. Like I said, another school made these. If these were all my materials, I would do every problem. But once in a while, I look at them and go, not crazy about it. So F is the number of people in a classroom. And M is minutes driving. And if you wanted to do it like we did our variables at the beginning, you'd say driving time in minutes, if you wanted to mimic that form that we did before. So M equals their driving time in minutes, and it's more than 20. Okay, that's the end of our first lesson. Your first 2 days of class are done. So I would stop at this point and work on your ALEKS. Like I said, for every hour you take notes, and you'll take an hour of notes every day, 4 days a week, then you should do an hour to 2 of homework. Then you go back and take an hour of notes the next day, hour or 2 of homework. Okay? Okay. Have a great day, and I hope you have a great first week of school. See ya.